Alright, so rather than teach you the process straight up, give you a rule straight up, I'm going to explain what this is and get you to figure the rule out for yourself. So, integrating is essentially the exact opposite of deriving. So to undo a derivative, we integrate. To undo an integration, we derive. They're interrelated, they're opposite operations in some regards. Cool? They get given a funky little symbol like this. Yep. Yep. They get given a funky little symbol like that. But like I said, the moment the teacher has asked you to undo a function. So I'm going to give you a function here that has been derived. So this function has been derived. You need to tell me what the original function was. So d dx of some function equals 4x cubed. What was the original function? About half the mean wall is about to open itself up to you, which is great. What was the original function here, Max? Have a guess. So what was the power? Let's start with that. What was the power? If it's now x to the power of 3, it was x to the power of 4, correct? Now when we derive, we have to take the power down and multiply it, correct? So if this is now 4, we have to then divide by what? So what was the original value? Just x to the power of 4, correct? Yeah. Wow. Yes. Yep, so our original function was x to the power of 4. What about this one? So this was before x to the power of 3. Now, we'd normally, if we were deriving, we'd take that down. So how did, what else needs to be added? Where's the 3 got to go? In there? Very good. So what's the rule? If we're integrating a function, what do we have to do to the power? Plus 1, so n plus 1, and then we have to divide by the new power, n plus 1. Cool? That's our rule. Now there's this plus c, and it gets really frustrating because you forget it all the time, and I'm going to forget it all the time, and some snarky kid in the room is going to say, plus c, every single time I forget it, and they're going to get great satisfaction. Good. It's a reminder, it's the only capital you have to make me remember to do plus c. And if I model that, then you're much more likely to do it in an exam. So continue to be snarky. Just know that it's grinding my gears. I'll talk about the plus c later on. Happy with that? Yeah, it does, but we'll just talk about that later on. Now, that applies. This rule applies exactly the same when we're dealing with square roots, when we're dealing with negative indices. We just have to make sure, just like in derivatives, we're representing our power as a negative or as a fraction. Does that make sense? So make sure we always represent our power as a fraction or as a decimal. You're good. 3 o'clock. Yeah, it's 3 o'clock comes in, just contact him. He should do, actually. You might need to get one past him and see if they might go through class today or just pick it up. Just let him do something. Yeah, so you can yourself.
Wait, so you say represent the power of a fraction negative or decimal?
Yep, so we'll do an example under here. Have we got those notes down?
Yeah.
We'll do an example. And the example, oh yeah, we've got the rule. So let's do a few examples because that's probably the easiest way to do it. So I think we understand what's going on. We'll get the rule and then we'll understand the application, but it is linked area. So I want the integral of the square root of that, for example. Okay? Well, I would firstly write that as the integral of x to the power of a half. I would add 1 to the power, which makes it x to the power of 3 on 2. And now I have to divide by 3 on 2. Now remember with that division, there's a long way to do it, but I can bring that 2 up the top. I can explain how that works, but just trust me for now. 2x to the power of 3 on 2 over 3.
So that's it.
You missed your snarky chance.
Oh, you missed the C, sir.
You got that plus C. Okay, happy with that? We'll go another one. Might as well do a couple of examples, we'll run it.
Wait, so you just leave it plus it.
Yep, has to stay there. It comes in later on with definites, definite integrals. These are indefinite. Don't worry about it. We'll talk about it later. There's more to come. So with this one here, our first step is to do what? 3x to the negative 2 plus 4x dx. I want you to write down what you think the answer is before I do, so you can get some form of feedback about how much you understand.
Wait, so the plus 4x isn't the C value?
No. So we just integrated the same we derive. Every new term we integrate separately. So if we were deriving 6x squared plus 4x, we'd derive the 6x squared, which becomes 12x, and then we derive the 4x separately, which will become 4. Cool?
Isn't there something we should put on the other side of the equal sign, or no?
Yeah, you should, but just for now, I'm just trying to get the process. That's good though, you're right, there should be something there.
Shouldn't it not be 3?
Why?
Staying 3 but negative 2
I haven't finished yet. Divide. So I bring the power up,
Yeah.
and then I divide by, I add 1 to the power, which makes it negative 1, and divide by the new power. Did you get that?
I got the second last straight off.
Yeah. That's alright. That's pretty much it. Did you get it? Vanessa, you get that? Okay, that's good. Max?
I got up to the second last.
You got that one, but you just didn't simplify it.
Yeah.
Dylan, how'd you go? Right? You get that?
Yeah, I'm on the third one.
That one?
Yeah, I don't know how you got to the last
Well, the negative 1, I just turn that back into on x.
one. Yeah.
So x to the power of 1 on the bottom.
Yeah.
And the negative, I can just represent that. I can represent that on the top of the bottom. It's just convention, we like to leave it on the top.
Yeah.
I cancel my 2's and I'm left with 2x squared, and the plus c stays by itself. It will get easier, but do you understand that and how that rule works? So this process is very strongly linked to what we're doing there. They're very much linked processes. The only thing is, this is like first principles, and this is what we actually use. So you're going to use this so much it'll become very simple. It tells us the same thing. If I wanted to do between 0 and 4, and there's a process that we do after that. But for now, we'll leave that.
We did now sign.
Hmm?
We did now sign.
Yes, that was what you did in your assignment.
This will be on 4 issue.